Hi, today we will be continuing with the demonstration for our project Save It. I would like to introduce our group members again, which include a total of 4 people. Pravindu, myself Arshad, Ravindu, and Hamza. For this second demonstration, we have made a few additions and improvements to our project after collecting and analyzing the data from our project. The tasks have been divided among the group members equally as shown here. Pravindu was in charge of assembling hardware and typing the code for our project. Ravindu covered the user stories, the system features, and myself, Arshad, created the timeline for the project using a burn-down chart. And lastly, Hamza created the Trello board to break down the tasks. Now moving on to the Sense, Think, Act paradigm. We had used 4 PIR motion sensors, 1 lux sensor, and 1 temperature and humidity sensor, and the latest addition of 1 sound sensor. These sensors were used to collect information about the surroundings in the room. The data collected from these sensors were then used to visualize and analyze our project for improvements and upgrades. For the thinking process, the motion sensors were placed at various points in the room to detect motion and determine whether a person is entering, exiting, or moving within the room. To further help with this, we added the sound sensor and placed it in the room to measure sound levels and to help determine if a person is present in the room. The lux and temperature sensors measures the light intensity and the temperature in the room respectively. These sensors are triggered only after it has been determined that a person is present in the room, which means that these sensors only work when the room is in an entered state. After it has been determined that motion is present inside the room, the acting part comes into play. If the light intensity measured by the lux sensor is below a certain level, the lights will switch on. If the temperature is between certain levels, either the AC or the heater will switch on depending on the temperature levels in the room. Now moving on to the Trello board. The Trello board had been divided into 3 components: the requirements, the prototype implementation, and the testing. The requirement part consists of the sensors, the hardware components, the code, and the research made for our project to be as realistic as possible. We also added a sound sensor, as you can see that the new additions have been highlighted. The prototype implementation component includes sound detection, motion detection, temperature and humidity data, and the lux intensity data, which are all used for analyzing the system to activate any of the appliances. We used LEDs to stimulate what our appliances would do, like switching on the AC, the heater, according to the situation analyzed by the collected data. For the testing part, we tested our system in modules. We tested each part of our code separately so that we know if there are any errors in between. We then compiled the code completely and tested it on our prototype. Moving on to the user stories. As for the client, a client would want to switch on the lights when it is dark, and he would want to switch on the fan or the heater when it is hot or cold. He would also want to switch off the lights, AC, fans, or the heater when not in use or when there's no one in the room to save electricity. As for a designer, the designer would want to create the system which will reduce the usage of electricity and to make a system that is convenient for the users. In the system features, we have switching on and off the lights, switching on and off the ACs, automatic control of lights and AC, ability to sense the presence of people in the room. Moving on to the burn down table. The burn down table had been edited a little bit after the additions and improvements to our new system.
Hi, my name is Syed Mohammad Hamza and today I'll be demonstrating to you a group project called Save It. I'll begin by explaining the hardware setup that we have used for our project. So as you can see here that we have used 3 PIR motion sensors, 1 lux light intensity sensor, 1 temperature and humidity sensor, and a brand new addition of a sound sensor that we have used in this project, for which I'll go into detail later on. We have also used 3 LED lights which will be representing our appliances such as the lights, ACs and fans. And we are using an Arduino board for our whole thing. Moving on, I'll be explaining to you how our system actually functions. So these two sensors will be placed on the door of our room in these positions. So sensor 1 will be placed on the door outside the room, and sensor 2 will be placed on the door inside the room. And so if a scenario occurs like if someone enters the room, sensor 1 will detect motion first, and right after that sensor 2 will detect motion. This will imply to our system that someone has entered inside the room. And in the same way, if someone exits the room, sensor 2 will detect motion first, and then right after that sensor 1 will detect motion. This will imply to our system that someone has exited the room. Now moving on to the code of how this actually functions, as you can see our enter check function here, it shows you a for loop in which our sensor 1 detects checks for motion for 1 second, and if there's motion present and for that 1 second, it will move on to our next sensor, and that will check if there's motion there or not. So if sensor 1 detects motion and right after that second sensor 2 detects motion, this will imply that there's motion, that someone has entered the room. In the same way, exit check also works very similarly to the enter check. The only difference here is that sensor 2 will detect motion first in this scenario, and then right after that sensor 1 will detect motion. Okay, so moving on, I will be explaining to you how our sensor 3 and sensor 4 will be working along with our sound sensor. So for our prototype, we are actually going to be using this one sensor to represent both our sensors, sensor 3 and sensor 4 in our room. And we are also using a new microphone sound detector sensor, which will be detecting the sounds inside of our room. So after entering inside the room, our sensor 3 and 4 will be always checking for motion inside the room, and if there's motion inside the room, our system will turn on and switch on the appliances accordingly. And for example, if someone is inside the room and they're not moving at all, so they're sitting and talking, in that situation our sound sensor will detect sound, and according to that our system will not turn off, which was a flaw in our previous prototype system, but now we have improved that with our sound system. So moving on to the code of our motion check function, we have a variable frequency which will be checking for how many dataset values for our motion are actually true. We'll be checking for 2000 dataset values within 10 seconds. So if the frequency is above 250, this will imply that motion is present inside the room, and it will change the state of our system to motion true. Oh sorry, motion present equals to true. In the same way, if the frequency is above 500, this will imply to our system that there's definitely someone present inside the room, and our whole system state will change to enter equals to true. Lastly, if the frequency is less than 10, this will imply that there is no one present inside the room, and our motion present and enter, both the states will become false. So moving on, I'll be explaining to you how our sound sensor works along with our system. So moving on, I will be explaining to you how our sound sensor works along with our system. So as you can see from the code, we'll be calculating 2000 data set values within 10 seconds, and these values will be averaged out for every 10 seconds, and we'll be taking the sum of all these average values into a variable called temps. And so after every 10 cycles, we'll be calculating the average of those values to calculate the average background noise. So if the average background noise is above 55 decibels, our average value will change to 55. So if the sound sensor detects the sound which is above 5 decibels above the average background noise, it will change our system's state to motion present, and it will not only work if our motion sensor detects a certain amount of frequency which is above 5, because if it's below 5, the sound could be coming from anywhere. If there's no motion present, this will be really unrealistic for the room. So we gotta use a system which actually uses the motion sensor as well. So if there's at least some motion inside the room and there is a sound present, that means that our system will change its state to motion present. So moving on to our actuators, how our actuators work, I'll be demonstrating to you how our light sensor and temperature humidity sensors are used to turn on lights and ACs. So as you can see from our serial monitor here, that there's no one entered inside the room, but our state is right now active, which means there's motion inside the room. So everything is switched off right now. As you can see, the heaters are off, the fans are off, and the lights are off. So if I put my hand on the light intensity sensor, this will show to you that the lights are turned on. For now, the lights are turned on, as you can see here, and if you can see here as well, the light is turned on, the LED is turned on. So in the same way, if my temperature value goes above 25, so now as you can see that the fan has turned on because the temperature value has gone above 26 degrees. Now as you can see here as well that the LED is turned on. It functions the same way if the temperature value goes below 10 degrees. The other LED will turn on as well, but we can't actually make it go below 15 degrees. So moving on to the code for our lux and temperature sensor. I'll start by explaining you the first if statement. This shows that if the difference between the two consecutive temperature values is greater than 10, those values will not be considered. And if the difference between the two values is within 10 degrees, those values will be considered. And it's the same for our light sensor, but the values used for our light sensor is actually 50 because light intensity is measured in a larger range than our temperature sensor. So as you can see that the if statement for temperature is that if the temperature is above 25, the fan will turn on, and if the temperature value is below 15, the heat will turn on. Heat is actually our heater. And in the same way as you can see here that if our light intensity is greater than 600, our lights will not turn on and they will switch off. And if they are below 200, the lights will turn on. So lastly, if our heater is on, it will not directly close as soon as the temperature is like 16 or 17. Once the heater is on, it will keep working until the value of the room temperature is at least at 20 degrees. And it's the same for our fan because the fan will only be turned on if the temperature value is above 25, but it won't be turned off until the value comes back to a value of 20. So this is a final system that we've created for our group project called Save It. I hope you like it, and I hope I have been able to explain all the system features properly. This has a lot of improvements from our previous prototype, so I hope you like it.
Moving on to the challenges we faced in our project. The highlighted challenges are the ones that we faced after the improvements and updates in our system. When implementing the sound sensor, we had to make sure that if the background noise of the environment were to increase due to some circumstance, like construction nearby or a rainy day, the system would not engage and will adjust according to its environment. The system we have implemented will record the sound data for 10 cycles of the system, which would be around 150 seconds, and this data collected will be used to calculate a new average sound. Therefore, an increase in the background noise of the room will be taken into consideration by the system. To create a system which is robust to false positives for an agreeable extent, our system will require at most 15 seconds of data collection to make sure of any motion within the room, which means a false positive will result in the system engaging for 15 seconds. The other three challenges faced were the ones that we faced previously as well, such as when detecting entering and exiting from the room. The system can be faulty if two people enter and one person leaves. To fix this, what we did was we had an extra set of motion sensors inside the room which will detect motion and will update the system to keep it activated. What we added to this was we added the sound sensor to detect sound and will also update the system. The system will switch off only if there is no considerable motion for 10 seconds and if the system is in an exited state. Thank you. We really hope that we were able to convey all our project ideas in this demonstration. We hope you liked our project.